Hello, and welcome to Astronomy Daily, the podcast that brings you the biggest news from across the cosmos. I'm Avery, and as always, I'm joined by the brilliant Anna.
Hi, Avery, and hello to all our listeners. We have a packed show today covering everything from drama in low Earth orbit to the ancient history of Mars.
It's going to be a great one. Let's start with a story that sounds like something out of a movie. A damaged spacecraft making an emergency return to Earth.
That's right. We're talking about China's Shenzhou 20 spacecraft. It was up at the Tiangong space station, but it's now being sent back to Earth uncrewed after sustaining some damage.
Damage from what? This is the scary part of space travel.
The suspected culprit is a micrometeoroid, estimated to be smaller than 1 millimeter. It appears to have caused a crack in the window of the return capsule.
Wow, less than 1 millimeter. It's amazing how something so tiny can be such a huge threat at orbital velocities. So, what happened to the crew?
Well, this is where the safety protocols really shine. The crew was forced to return to Earth on a different vessel, the Shenzhou 19, which was docked as a lifeboat. This is actually a first for China's space program, having to use a backup ride home like this.
That's a testament to good planning. So now they're bringing the damaged capsule back on its own to figure out exactly what happened.
Exactly. The uncrewed return will allow engineers to inspect the damage up close. It's a critical learning opportunity for understanding the real-world risks of orbital debris and micrometeoroids.
Absolutely. Now, from the dangers in our cosmic neighborhood, let's zoom way out to look at how a galaxy's neighborhood shapes its entire life.
Right. This comes from a huge project called the Deep Extragalactic Visible Legacy Survey, or DEVILS for short.
Gotta love the acronyms. So what did the DEVILS survey find?
It confirmed something astronomers have long suspected, that a galaxy's local environment, its neighborhood, has a huge impact on its evolution.
So it's cosmic real estate. Location, location, location.
Pretty much. The data shows that galaxies in more crowded environments, like dense galaxy clusters, have much slower star-forming rates compared to their more isolated cousins out in the cosmic voids.
That makes sense. In a crowded cluster, there are more gravitational interactions, more mergers, and processes like ram pressure stripping, where a galaxy's star-forming gas can be torn away as it moves through the cluster.
That's the leading theory, and this new data release from DEVILS provides some of the strongest evidence yet to back it up. It helps us understand why some galaxies are vibrant and full of new stars, while others are old, red, and retired.
It's cosmic evolution in action. The DEVILS survey is essentially creating a census of these different galactic lifestyles, helping us piece together the complete life cycle of galaxies across the universe.
A fascinating study indeed.
Speaking of crowded environments, things are getting very busy right here at home. This week is absolutely jam-packed with launches.
It really is. There are 10 orbital launches on the calendar. Let's run through the highlights.
Leading the charge, as usual, is SpaceX. They have a staggering 5 Starlink deployment missions scheduled for this week alone. The internet constellation just keeps growing.
Then, over in French Guiana, Arianespace is set to launch South Korea's COMSAT-7 satellite, which is a very high-resolution Earth observation satellite.
And don't forget Rocket Lab. They're launching from New Zealand carrying the RAISE 4 demonstrator satellite for JAXA, the Japanese space agency.
And speaking of Japan, their own new heavy lift rocket, the H3, is slated to launch a crucial navigation satellite for their national GPS system. Plus, China has 2 of their own launches scheduled. It's nonstop.
That H3 rocket launch for Japan is particularly significant, isn't it? They've had a few setbacks with that program.
It is. The H3 is Japan's next-generation flagship rocket, designed to be more affordable and flexible than its predecessor. A successful launch is crucial for securing Japan's independent access to space and for competing in the commercial launch market. This mission will be a major test of its capabilities and reliability after a failure on its debut flight.
And the COMSAT-7 for South Korea, what's its primary role?
COMSAT-7 is a powerful reconnaissance satellite. With its very high-resolution imaging, it can be used for national security, disaster monitoring, and managing natural resources. It's part of a growing trend of nations developing their own advanced Earth observation capabilities.
It really shows you the current pace of the global space industry. Okay, from low Earth orbit, let's journey to a place that was once much more active, the surface of Mars.
This is one of my favorite stories this week. A new study has produced an incredible map of 16 massive ancient river drainage systems on Mars.
16 separate systems? Are we talking about small streams here?
Not at all. The study says these systems are similar in scale to some of the large drainage basins we see on Earth. And get this, combined, these 16 systems transported nearly half of all the sediment that was ever moved by rowers on Mars. They were enormous.
Half of all the sediment. That's mind-boggling. It paints a picture of a very different, very wet ancient Mars. And I assume this has big implications for the search for life.
Absolutely. The researchers identified these locations as extremely promising places to search for signs of past Martian life. If life ever existed on Mars, these ancient water-carved riverbeds and deltas are some of the best places we could possibly look for evidence.
It's incredible to think about how they pieced this together. How do they map rivers that dried up billions of years ago?
They use high-resolution topographic data from orbiters like the Mars Reconnaissance Orbiter. Scientists can trace the faint outlines of river channels, deltas, and alluvial fans carved into the landscape. By analyzing the geology and the mineralogy, looking for clays and carbonates that typically form in water, they can confirm these were indeed liquid water environments. It's like planetary-scale archaeology.
And if we do send a rover there, what kind of biosignatures would they look for? Not fossils, I imagine.
Probably not complex fossils. They'd be searching for chemical biosignatures, specific organic molecules or isotopic ratios that are difficult to explain through non-biological processes. Finding preserved microbial mats or stromatolite-like structures would be the absolute jackpot, but chemical traces are a more likely target.
Well, let's hope a future rover gets to visit one of those spots. Okay, while Mars's water is long gone, our own star is incredibly active right now.
That's an understatement. The sun just unleashed a powerful X-1.9 class solar flare.
And as a reminder for everyone, X-class flares are the biggest and most energetic category. This was a major event.
It was. It erupted from a newly emerged sunspot region and caused a strong shortwave radio blackout over Australia and the surrounding region.
But that's not even the main event, is it? There's something bigger on the horizon.
Correct. The sunspot region that caused this flare is concerning, but an even larger and more complex region is now rotating into an Earth-facing position. This is the very same sunspot that was responsible for the powerful flares and incredible aurora displays we saw last month.
So space weather forecasters are watching it very, very closely. We could be in for another active period.
Indeed. And it's important to remember the potential impact. A strong Earth-directed coronal mass ejection, which often accompanies these big flares, could disrupt our power grids, damage satellites, and interfere with GPS and communications. We're far more technologically dependent now than we were during the last major solar maximum.
So this isn't just about pretty auroras. There's a real need for accurate space weather forecasting to protect our infrastructure.
Exactly. Agencies like NOAA's Space Weather Prediction Center work around the clock to monitor the sun. Their warnings give satellite operators time to put their spacecraft into safe modes and utility companies time to prepare their grids for potential geomagnetic disturbances. It's a critical and often unseen line of defense.
Definitely. Now, all this activity we've discussed, the launches, the satellites, the debris,
It all leads into our final story, which is about finding a sustainable way to operate in space.
Right. The growing problem of space debris. What's the new idea for tackling it?
Experts are strongly advocating for what they call a circular space economy. The idea is to move away from the traditional model of launching something, using it, and then abandoning it in orbit.
So it's about applying the principles of recycling and reuse that we talk about on Earth, but in orbit.
Exactly. This means designing satellites and spacecraft for durability, for easier repair, and for potential reuse or recycling of their components. It also involves creating multi-purpose space stations that can serve as in-orbit repair and refueling depots, and developing technologies to actively go and recover existing debris.
It's a huge but necessary shift in mindset. If we want space to remain accessible for future generations, we can't keep treating it like an infinite resource.
That's the core of the argument. It's about building a sustainable future, not just for Earth, but for our activities beyond it.
It seems like a monumental task. Are there companies actively working on this technology now, or is it still mostly theoretical?
Oh, it's very much moving from theory to practice. You have companies like Astroscale developing satellites designed to capture and deorbit space debris. Others are working on robotic arms for in-orbit servicing to repair and refuel existing satellites, extending their operational lives. Even NASA is investing in technologies for in-space manufacturing and assembly, which reduces the need to launch massive monolithic structures from Earth.
So the building blocks are being put in place. It's not just about cleaning up the mess, but also about building smarter from the start.
That's the fundamental shift. Sustainability has to be part of the design process from day one. It's an investment that will pay off by ensuring that the opportunities of space remain available for the long term.
I couldn't have said it better.
A perfect note to end on. And that is all the time we have for today's journey through the latest in space and astronomy.
From near-Earth challenges to the grand scale of the universe, there's always something new to discover. Thank you for tuning in.
I'm Avery.
And I'm Anna. Join us tomorrow for another episode of Astronomy Daily. Until then, clear skies, everyone, and keep looking up.
Astronomy.